Alright, how's it going, everybody? My name's Oliver, and I'm going to do a little bit of the Cyborgs programming tryouts. I'm one of the co-heads of leadership, along with Tobias and Danak. And let's just get straight into it. Let's go! Alright, so you're interested in programming. I'm just pulled up repl.it here. We have an assignment on Google Classroom about how to use repl.it in case you never used it before. But basically, I've gone onto repl.it.com. I've signed in. You can just create a repl.it, and we're gonna be using Java. And I'm just gonna call this Cyborgs Programming Tryouts. Alright, so you're interested in programming. What is programming? Basically, programming is how we tell a machine how to do what we want it to do. Have you ever played a game, used your computer in general, used your web browser? All of this was coded by someone, a long time ago or sometimes very recently. Alright, so what's repl.it? What are we doing in here? When we put letters in here, this is our code. Over here on the left, this is our code. Over here on the right, our console. That's what we're going to be using to run the code and to look at the output of our code. So what's going on over here? This is our code. Here we write in what is somewhat human comprehensible words, and this gets compiled into machine code and then is run by the computer to produce our output. And we use Java. So what's Java? Java is a programming language. There are a lot of different programming languages out there. You've probably heard of Python, C#, C++, Ruby, tons of different programming languages out there. They're all slightly different, all have slightly different functions or uses. But in the Cyborgs, we use Java. And basically that just changes like the syntax around most of the time and how we code our programs. So let's do a little bit. Let's get a little bit of coding in here. So when you start a repl.it, you're gonna get started off with this template basically. So you're gonna see a lot of stuff: class, main, public, static, void, main, string, args. What is going on? The most important thing to know right now is that inside of this main function, that's the code that's going to be run when we click the big green run button up at the top of the screen. And so we call this our main function. And how do we know when it starts and stops? We can see we have an open curly braces or open curly brackets and closed curly brackets. You can see that's above the normal curly brackets on your keyboard to the right of the O and P keys. So let's get started. Let's do a little programming. Alright, so one of the most important fundamentals of programming, if you've coded, you probably heard about this before, but you have a lot of different data types. What are data types? What does that mean? What are we talking about? So you've probably taken algebra or taking algebra in class, so you know what a variable is. If I wanted to say in math, I would say x equals 5. Alright? You see, we automatically get red underlines, but whatever. X equals 5. We want to kind of replicate that in a more formal sense a little bit. What does that mean? Well, we say x equals 5. What is 5? 5 is a integer, right? It's a whole number and it's negatives. So we want to tell the computer that it's an integer. And to do that, we use the keyword int, short for integer. And you know how if you write in an English sentence, at the end of every sentence you have to put a period, right? Otherwise it's not a complete sentence. It's, answering complete sentences is what you see on all the assignments your teachers give you. So if we put a period here, we don't use periods in programming because we could think that this is a decimal point, and we're not using decimal points here. So instead what we use is a semicolon. Basically tells the computer, this is the end of our statement. That's it. And then we move on to the next statement. If we then wanted to create an integer, and we want to call it, let's say, y, we could say that that's equal to 90. You know, any integer. It could be equal to negative 90. It could be equal to 0. And so now we have two integers, x and y, and these are both variables. And you can see this is similar to math class. You use an equal sign to assign it a value. Alright, so we have two integers, x and y. What do we do with that? You can make a bunch of integers in here. You can say integer x integer x2 equals 90. Integer. And you can name variables whatever you want. You can say I want to name this one cyborgs. And I'll set it equal to 1155. Right? Team number. So we can send it to a bunch of values. What are some other data types that we can use? Well, let's say we don't want to work with integers. Some things in life don't come in whole number groupings. Well, let's say we want to use a decimal point. Well, there's actually two types of variables that we can use to do that. One is called the float, and we can also give this a name, let's say nice, and this equals 69.420, right? Cool. Cool. You see, it's gonna give us an error because we want to indicate to the compiler that it is a. Is the compiler acting up? It is a float. We call it a float because it's a floating point number. It's basically a fancy way of saying it has some decimals after it. Or if you have like a fraction, you can represent fractions as decimals, and that's what we do here. Float basically just means it's a floating point number. The decimal point can move around. But over time, floats, if you look up floats, over time, we've needed more accuracy than is stored in a single float. So what we've really, upgraded to is something called a double. It's called a double because it kind of has double the precision of a float. And we can call this one cool. The variable names, eventually we'll get into what's a good variable name and what's a bad variable name. But for now, we can just name it cool. And let's just say this is 52.565. I don't know, random number. You see, we don't need to put an F after it because it's not a float, it's just a double. And the double, we use doubles so often that they basically become the norm. We kind of rarely use floats. Well, in your day-to-day life, we don't all just talk in numbers and decimals and integers. So let's say we want to contain some text in our program. How would we do that? So, we would use something called a string. Now, a string is also a data type. It's not a primitive data type like integers or floats or doubles, but we'll get into what that means later. But for now, string is just it's a data type, and we're gonna call this string, text. Because it stores some text, and again we can see we're assigning it using the equals, and let's say this equals hi, how are you? And again, you need a semicolon at the end of the line because we're ending this statement. String text, how are you? So a string basically stores a bunch of different. It stores imagine it as like a dialogue, or you can store really anything in here. Not really anything, but anything that you want to represent as text. So what can we do with this? We can assign a bunch of operations a bunch of variables in our program, but we're not doing anything with this. You even see our compiler is giving us a and helpful warning, I guess. The value of local variable nice is not used, or value of local variable cyborgs is not used. So we gotta do something with these variables, otherwise, they're kind of just useless and they're stuck in the program, in the code over here. And you can see if we were to run this program, after a while, nothing will be outputted because we're not telling the compiler, we're not telling our computer that we want anything to be outputted. You see, we have no output. So how do we tell our computer, well, I want to see what's in this cyborgs variable. So for that we use system.out.println. This basically tells us in our system, our computer, the output out. We want to print a line. We can also just say print, but the line basically puts a return at the end, or moves on to the next line after we're finished. Anyways, system.out.println. You'll see this a bunch in programming. Whenever we do something, a lot of times we'll use system.out.println, for debugging or just for our program. So you can also see we have system.out.println. We can also say we have some parentheses here. So why do we have the parentheses? Well, this basically tells the computer whatever. It's finally finished, I guess. You can see nothing was outputted. This basically tells our computer, well, anything inside these parentheses is what we want outputted to the system. And so, let's say we want to send the value of cyborgs to our console. So let's see if we run. I think repl.it is being a little bit slow right now. Oh no, you can see we get 1155 because that's what the value we put in cyborgs. Now we can do a few operations if you know from class, if you know from math in general. You can add 100 and you get, as you expect, 1255. You can subtract 100. You can multiply by 100. Let's just say multiply by 7 because I don't know how to multiply by 7 off the top of my head. And we can also divide by 100. So that'll do something weird. So let's just do divide by 5. And you can see we get a bunch of different outputs. Each of them are on their own separate line. That's why we use the print line. If we were to use print, I'll change them all out right now. You can see they'll all be printed on the same line because we're not designating each of them their own separate line. So you can see we get this mess over here. You get plus 100 minus 100 times 7 and then divided by 5. Bunch of gibberish. So that's why most of the time we'll be using print line. And we can pass in any of the variables we made up there. Any of the variables we made up there to our print line function. Let's say we want to print what's in text, or what's in nice. And see if we run, we'll get what's in text or what's in nice. So system.out.println basically tells us what's in a variable or tells us the output of some, multiplying it by 7 or whatever. Alright, great. So this is powerful within itself. If you want to multiply something by 7, that's pretty good. It's good at doing that. It's good at doing a lot of arithmetic. But it's not very complex. Like every time I want to print 100 cyborgs plus 100 or cyborgs minus 100. What if I wanted to sometimes print plus 100 and sometimes print minus 100? Well, for that we're going to need something called an if statement. So if, one of the biggest keywords in programming, if the syntax goes if whatever is in these parentheses, then do whatever in between these brackets. So let's say we would also have some code in here. So I guess there is also a type I left out over here. Boolean. That's just got lowercase b. Boolean. What a Boolean is, it's true or false. If you've done the logic unit in math class, you know, true or false. Boolean, we can call this compare, and we can say true or false. You know, something, we can say true. Compare true. So what we do within this if statement is, in these parentheses, it's going to want either a true or a false. A true or a false. And if this evaluates to true, then it's going to run whatever in these code brackets. So let's do that now. So let's see, system.out.println, you know, the if statement ran. Just delete this for now. And say, whatever in here, this, shoot, I forgot my semicolon. You might run into errors sometime. Forget semicolon, stuff like that. And see, what's inside here is true, so the if statement ran. Whatever is in between these curly brackets ran. Let's say we change this to false. Then we can see nothing got outputted because the if statement did not run. So we also have a lot of comparison operators. What does this mean? So let's say we wanted to see whether nice was less than cool. You know, is 69.420 cool? Nice. Is that less than cool? 52.565. You know, let's see. No, nothing got outputted, so it's not less. Surprise, surprise. You know, 70 isn't less than 53. If we now say nice is greater than cool, the if statement ran, right? So this is true. Nice is greater than cool, so whatever in the if statement ran. Before, when we had nice is less than cool, thank you. Nice is less than cool, that was false, you know. So whatever is inside the if statement did not run. Well, okay. So let's say we wanted something to run if we also let me sum this up. We also have a bunch of different comparisons. We can say less than or equal to. We can say greater than or equal to. We can say not equal to. This exclamation point a lot of time will be not. So if something, we can see, if we say not false, you can see we get not false, false, the opposite of that, true. So the if statement runs because this inside here evaluates to true. Anyways, if we say if nice is not equal to cool, which is the case here, right? 69 and 52, 50 point a bunch. You can say they're not equal, so the if statement ran, right? Nice is not equal to cool, that's true, so the if statement ran. Now let's say we want to do something if nice is greater than cool, and then if nice is less than or equal to cool. You know, and say system.out.println, right? And we can say the second if statement ran. Semicolon. And let me change this to first. Alright, so let's run this. You can see nice is greater than cool, so the first if statement ran. If we changed nice to 40, then we can see that nice is less than or equal to cool, right? So the second if statement ran because this evaluates to false, so the first if statement ran, and this evaluates to true, the second, because nice is less than cool. So the second if statement ran. So let's say we want to condense this. Let's say if nice is less than cool is greater than cool, we want this to run. Otherwise, we want this to run. You know? So how do we do that? We do that with the else keyword. So let me copy. We do this with the else keyword. So what does this else keyword mean? It basically means, well, if this is true, then this part runs. If it's false, else, if whatever in the statement is not true, it is false, then we want something out here to run, right? System.out.println the else statement ran. So let's run this, and we can see nice is less than cool, so this evaluates to false. And so we said, well, this isn't true, so in case this isn't true, else we want to do this. So we print the out system.out.println system else statement. The else statement ran, and you see that's our output. So let's say you want something to happen if this isn't true, right? If nice is greater than cool. So what if we also want to check if nice is equal to cool? And you can see here we actually use a double equal sign. The reason for that is when we use a single equal sign, we're assigning it a value, right? Like in the variables up here. Say x equals 0, x equals 5, y equals 0. Here we're checking if two variables are equal, so we use two equal sign. Important. Sometimes that'll trip you up. So if nice is equal to cool, we can say system.out.println nice is cool. Pretty descriptive thing. Okay, so let's say else if nice is not equal to cool, and if nice is not greater than cool, let's say else else. And we can also have something in here, system.out.println nice is less than cool, right? And figure that if it's not greater than cool, if it's not equal to cool, it must be less than cool. So you can see we can do what are called nested if statements. Basically, we put an if statement within another if or else because they're very connected. So we call them nesting because it's like a Russian nesting doll. This is the outer layer, if, and then this is the inner layer, the second if. Right, and you can see if we had a lot of checks. We're gonna run this. You can see if we had a lot of checks. Let's say we want to do something in here. Check if none of the things are true. If nice minus 5 equals cool, then we could have something in here. But you can see we're gonna get a lot of curly brackets up here, and it's gonna get harder and harder to read because it's like, okay, if nice is greater than cool, then else, and then if it is equal to cool, then else, and then if this can get very hard to read very quickly. So we have a very nice way of condensing this down, and that is something called the else if. If you've used Python, you know it as elif. Just a shortened way of saying else if. So what does this else if do? It's basically a combination of what we saw before. If this turns out to be false, else we want to check if something else is true. So let's say in here we say nice is equal to cool. Then we want to print out nice is cool. Right? Sorry, let me just delete this. Nice is equal to cool. We can see run. You can see nice is not greater than cool. Nice is not equal to cool. Let's say we set them equal, 565. You can see they are equal. So this thing down here should, but it's not for reasons that I will not talk about here. But anyways, let's say we say x and y are 0. If x is equal to y, you can see we don't have to use the same variables we did up here. It's just, if this above statement is not true, then if this is true, print that. Nice is cool. Maybe I should say x is y. You know, whatever. We can have whatever is in there. You can say else if. That's the important keyword. If this is not true, we want to check if this is true, and then we can even keep on chaining these. We can say else if, you know, nice is less than cool. And say we can print system.out.println nice is less than cool. And we can say, we can even have another else in here. We can say system.out.println nice none of the above. Right? Let's run this. None of the above. Semicolon. Always the dang semicolons. That might trip you up in your own program. You can say we got x is y, right? Because 0 is still equal to 0. This if else statement still runs up here. And let's say we say x. Let's change this to 40. Let's change this back to 5. You can see, well, nice is greater than cool. Not gonna happen. X is equal to y. Not gonna happen. Nice is less than cool. True. So that's what we get. Nice is less than cool, because that's what we put in our else if block in here. Remember, defined by these open and closed curly brackets. So that's a lot of what we're going to be doing in this program. And there is something else I want to touch on. You know, for a lot of the algebraic operations, we have asterisks. For multiplication, we have plus for addition. We have minus for subtraction. We have a slash for division. You know, if you ever used an online calculator, you'll know this kind of notation, or those ways to write them. But for some other operations that aren't so simple, let's say we wanted to raise something to the power of something else, then we have to use math system.out.println. Say we want to print something. Let's say we want to square the cyborgs variable, right? When I see what 1155 is squared. I don't know that off the top of my head. So how do we do that? Cyborg. Well, obviously we could do cyborgs times cyborgs, right? And that'll get us our answer. But I don't want to write the cyborg twice. And let's say I want to raise it to the third power. Should I write it like this? You know. And then let's say I want to raise it to the fourth power. Should I write cyborgs? And you can see this kind of repetition is something we usually aim to avoid in programming. So how do we condense this? Well, we're going to use something from the math library. So to do that, we have this important thing, math dot. So we want from math dot, you know, something within math. We want to do pow. In this example, let's say 1155 or cyborgs, right? So that's what we use. Let's say we want to raise that to the power of x. You know, cyborgs to the x. You can see that's much simpler to do, and we can even E15. That's why it's a very large number when we raise it to 5. Let's say we just do 3. let's see, cyborgs raised to the third. It's much easier to change, right? Even now, because we can multiply instead of having to times cyborgs, and add or delete those. We can just say, oh, math.pow cyborgs. Let's say we want to raise it to the power of 2. If you want, you can raise it to the power of 1/2. I think this might actually not give us 1/2, but yeah. For let's say 0.5, 1 divided by 2 is not 1/2. You might get a little bit confused. Well, that's something we can talk about later. Anyways, 0.5. Something to the power of 0.5. That's the square root. Something to the power of 1/2 is the square root. From math. We use a lot of math in programming as well. And let's say we want to raise it to the power of whatever else, right? So math.pow, very helpful. There are a bunch of other functions in the math. Again, we do math.sign. So let's see, we get the sign of 1155. It's probably not going to be too helpful. Yeah, the number's kind of meaningless. But we can perform a bunch of operations on this cyborg's variable. We can take the square root. We can do math.pow to the 0.5, or we can use math.square root. It should really be equivalent, and you can see we get the same answer, because raising to the power of 1/2 is the same as taking the square root. And you can investigate for yourself. You can see there are a bunch of other functions. There's tan. If you run down here, you can see this is a little preview of the functions that it thinks you might be trying to use. Tan, tan-h, 2 radians, 2 degrees, a bunch of functions. But for now, we're just going to stick with square root. And run as well. Same thing that we had before. And for our programming tutorial, that's pretty much all we're going to do for now. So, just as a general review, we learned what variables are, the different variable types, integers, floats, doubles, booleans, and strings. We know we can print something to the console over here. You can see console using system.out.println or system.out.print. And we learned some basic arithmetic operations, if statements, if else, or else if, I should say, else if, I keep on typing P, and then else, and we also learned some mathematical functions, powers, and square roots, for which we use the math library. And that's basically going to conclude it for these first tutorials. I probably made it a bit too long, but I hope you guys enjoyed, and I'll see you next time. Good luck.